So 8.3, the new function of composition. So we have, similar to 8.2, we have two different functions. Here we have a g function, which is 2t plus 4. And we have an f function, which is 3t minus 1. And here's my instructions. Find g of f of t. The way that we say that is g of f of t. It's important to be able to say the math out loud, so that's why I write that down right on here as part of your notes, g of f of t. Another way to write this would be g of the f function. So we could literally write this in this way, or g of f of t. So there's different ways to write it, but this is the one that we will see most often. And what this means is we're going to take the f function and we're going to insert it into the g function. So we're going to take this 3t minus 1 and insert it into the t spot. Sort of like an 8.1 on the back, where we inserted variable expressions into our functions. So we can rewrite this as g of, instead of writing f of t, we'll write the equivalent expression, which is 3t minus 1. I know that's yellow. Can you guys see that? So we have inserted the f function into the g function, and now it should seem very familiar from 8.1. So we just, where we see the t, we put in whatever's inside those parentheses. So we put in the 3t minus 1, kind of like your slider, right? Whatever's in here goes in here. And then we just distribute and simplify. So 6t minus 2 plus 4. And then combine like terms. The minus 2, the plus 4, so this is 6t plus 2. Final answer. Number 2. Here's my instructions. Find h of g of t. So I take and I plug my g function, which is, my g function is 2t minus 3. So I'm just replacing this with its equivalent expression, 2t minus 3. So h of 2t minus 3 equals, where there's a t, I'm going to write my g function in, 2t minus 3. Whatever's here goes in for your variable. And then minus 1. Now we can just simplify, so that's going to be 2t, and then the minus 3 and the minus 1 make a minus 4. I'll do 2 more. You guys pick. Shout out your favorite number. 19? 10. That's what I heard first. Okay. So I'll do 10 and then 19. Not 19, though, because that's an extra credit one. Okay, 18. Sorry, 18 first. So 10 and 18. So 10, we have our g function, and we're inserting our f function into it. So that is going to look like g of negative 3a plus 3 equals, it's going right in, oh sorry you can't see that, it's going right in for the a value. So 3 times whatever's in here, It's negative 3a plus 3, and then plus 3. What's my next step? Distribute, yep. Distribute the 3, so I get negative, so 3 times negative 3 is negative 9a, and then 3 times 3 is 9, and then we have our plus 3. We can combine the 9 and the 3, and what do we get?
12.
Yeah. Good job, Hannibal. Negative 9a plus 12. You guys feel like you're getting the hang of this?
Yeah.
So we
Sweet.
multiply that and the negative 3,
Mm-hmm.
and then do we multiply 3 times 3 too?
Yep. Number 18, last one we're doing together. So number 18, here we have h of g of x. Taking my g function, plugging it into my h function. This is a key step. Don't skip this step here where we rewrite this as h of the equivalent expression. That's going to help us out a ton, because then when we go to rewrite it, we go, what goes in for x? Oh, whatever I have here. So that's the 2x plus 3 goes in. And then minus 4. Then what?
4 times 2.
Uh-huh. So we have 8x. 4 times 3 is 12, good. And then subtract the 4. Mm-hmm. So we get 8x plus 12 minus 4 is 8. There you go. Composition of functions. You learned a new operation today.